easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
3, 2, 1,
0,
and liftoff. Liftoff. Americans return to space as Discovery clears the tower.
Discovery, roger, go at throttle.
Discovery, go at throttle up.
Discovery, roger, go for deploy.
Discovery, Houston, 20 seconds to LOS T-Dress.
Roger, nice to be in orbit.
Discovery's 4 computers now have primary control of critical vehicle functions.
Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Voyager's approach to Jupiter, the celestial body that so fascinated Earth's first modern astronomer, Galileo. Passing through the boundary where the supersonic solar wind slams into Jupiter's magnetic field, the spacecraft's instruments recorded a strong ball shock. Named after Jove, the supreme god of Roman mythology, Jupiter is an enormous whirling sphere of turbulent gases, big enough to hold over 1,300 Earths. The Voyagers discovered thin rings of dust encircling the planet, tiny grains containing silicon or carbon, like a fine haze of ash and smoke. Jupiter's atmosphere displays a dazzling variety of alternating patterns. Cold, light-colored zones dominated by ammonia ice crystals in the higher altitudes, and warmer, dark belts of solid sulfurous particles in the lower altitudes. Voyager's cameras afforded scientists spectacular close-up views of the Great Red Spot, a storm 3 times the diameter of Earth raging in Jupiter's atmosphere. Voyager atmospheric scientist Dr. Andrew Ingersoll.
The Great Red Spot is a counterclockwise rotating storm, sort of like a hurricane, that has persisted for over 3 centuries. We were amazed that this spot could survive in the midst of all this turbulent activity.
With at least 16 known moons, Jupiter could well be considered a mini solar system. The Voyagers flew by the 4 largest, finding Callisto pockmarked by craters, Ganymede etched by icy parallel grooves, Europa smooth and icy, and Io glowing a cold and sulfurous red-orange. 9 active volcanoes were found on Io, the first observation of live volcanoes beyond Earth and Venus. These geysers were spewing hot, sulfurous gases 100 miles, high enough to hit a passing satellite. Voyager project scientist Dr. Edward Stone.
If I were to pick one discovery to represent the body of discoveries that Voyagers made, I would pick the discovery of the volcanoes on Io. These were totally unexpected and really forced us to reconsider our whole concept of the evolution of small moons which are orbiting the outer solar system.
Pulling away from Jupiter after a joint reconnaissance of more than 6 months, the Voyagers got a healthy boost from Jupiter's orbit and made a beeline for Saturn. Mystifying man since the dawn of history, Saturn bears the name of the mythological god of the harvest, who reigned in the Golden Age. Traveling at more than 55,000 miles per hour, Voyager 1 arrived in November of 1980, only 12 miles off course after an interplanetary journey of more than 1 billion miles. Voyager's instruments found Saturn's atmosphere to be a cold ball of hydrogen and helium gases, racked by huge whirling storms and whipped by winds of up to 1,100 miles per hour. Saturn's magnificent rings, thought to have been the result of collisions between earlier moons and asteroids, consist of thousands of particles, swirling pieces of rock and ice, streaked like the grooves in a phonograph record. Voyager atmospheric scientist Dr. Andrew Ingersoll.
What Voyager discovered was the incredible structure in the rings. Saturn's rings are really composed of countless numbers of particles, ranging from the size of dust and perhaps larger particles the size of houses. These particles are constantly bumping into each other. These grooves are there because the rings are constantly being disturbed by satellites orbiting in with the smaller ring particles themselves.
As the Voyagers swept by, sunlight penetrated, backlighting and brilliantly illuminating the splendor of the rings, like the spokes of a gigantic Catherine wheel.
The Cassini mission ended this morning, high over the clouds of Saturn. The spacecraft is gone. Thanks and farewell, faithful explorer. But the legacy of Cassini has just begun. The effect that Cassini has and will have on the future of planetary exploration will go on for decades. Thank you, and long live Cassini. There are times in this world when things just line up, when everything is just about perfect. A child's laugh, a desert sunset, and this morning. It just couldn't have been better. And if you think about that moment where we've been waiting for this entire 7 years, everything clicked out just right. And then we can step back and say the same thing about the Cassini mission. A superb machine in an amazing place, doing everything we could possibly do to reveal the mysteries and secrets of our solar system. This morning, a lone explorer, a machine made by humankind, finished its mission 900 million miles away. The nearest observer wouldn't even know until 84 minutes later that Cassini was gone. To the very end, the spacecraft did everything we asked. That ground system support was superb, and we believe we got every last second of data.
During that time, we traveled 4.9 billion miles. We did 293 orbits, all unique orbits around Saturn, shaped by the navigation team and by the spacecraft team, by the nav saying, point here and go change your speed this way, and the spacecraft performing it flawlessly.
And when I think about Cassini, I think Cassini's final gift to humanity was the fact that we knew the day, the hour, the minute, and now the second of the plunge. And so we could gather together with the scientists, the engineers, with the public, with our own families. You can think of us as a giant worldwide Cassini family and share this final moment of the plunge and have that memory to add to our Cassini scrapbooks. And if I had one thing I could say to Cassini, I'd say, goodbye, Cassini. Thanks for the ringside seat at Saturn. And as Thomas said, we'll be back.
Voyager 1 flew within 2,500 miles of the surface of Saturn's largest moon, Titan. One of only 3 moons in the solar system known to have an atmosphere, Titan may help unlock secrets to the origins of life. Voyager project scientist Dr. Edward Stone.
Certainly one of the more exciting discoveries at Saturn was the atmosphere of Titan. It's an atmosphere which is mainly nitrogen like that here on Earth, but which contains methane, so that the photochemistry going on there today may resemble very strongly that which occurred here on Earth billions of years ago before life evolved.
By swinging around Saturn, after a close-up view of Titan, Voyager 1 was propelled out of the plane of the solar system and is now traveling toward interstellar space. First detected in 1781 by English astronomer Sir William Herschel, Uranus, in Greek mythology, is the name for the heavens. 5 years and almost 1 billion miles after leaving Saturn, Voyager 2 reached Uranus in January of 1986. Like all the other planets, Uranus spins like a top, but tipped over on its side. Strangely tilted and off-center, Uranus's magnetic field extends in a bizarre corkscrew tail millions of miles into space. its magnetic poles are also wildly askew. Voyager 2 discovered 2 new rings. Dark, narrow, thin bands of ice, rock, and dust with particles the size of a fist. Although Voyager 2 discovered 10 new Uranian moons, the most eagerly anticipated event was the close encounter with Miranda, one of the most bizarre moons in our solar system. Close-ups of Miranda revealed a strange and wondrous landscape, including a canyon 12 miles deep. Miranda may have collided with another moon, shattered, and then by the force of its own gravity, slowly reassembled itself into this chunk of rock and ice. These digitized photographs are a silent testament to the violent origins of our solar system.
It is an ice giant, a planet of monster storms, and a recluse rarely seen that is 30 times farther from the sun than Earth. When you find this elusive planet that appears as a mere dot in most amateur telescopes, remember that you're actually viewing a planet with a thick atmosphere that is composed of massive amounts of hydrogen and helium with traces of other gases. That atmosphere surrounds a solid interior of rock and a warm mantle of dense fluid deep beneath the clouds. This opposition event also comes just after the 30th anniversary of the Voyager 2 spacecraft's flyby of the planet in 1989. Voyager 2 provided our closest glimpse of Neptune, passing about 3,000 miles or about 5,000 kilometers above its north pole. The pictures Voyager 2 sent back gave scientists a new snapshot of weather in the extreme, including a dark and violent vortex that looked similar to the Great Red Spot on Jupiter. Since then, observatories such as the Hubble Space Telescope have given us additional observations of the planet from afar. NASA scientists have learned, for instance, that unlike Jupiter, the Neptune vortex disappears for a time, and then similar storms appear later. Scientists have determined that Neptune has seasons such as those on Earth, but that these are much longer, spanning decades instead of months. By studying these seasons on a continual basis, scientists look to gain a better understanding of the similarities and differences of atmospheres on other planets, including right here on Earth. So consider taking a look at the ice giant planet Neptune in September, and you'll see why it captures the imagination of so many scientists and astronomers. Grab your telescope, step outside, and enjoy the view.
Approaching Neptune, after 12 years on the road and another billion miles, Voyager 2 was an exhausted traveler. By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune, the last stop on its spectacular grand tour of the 4 outer planets. Discovered in 1846, Neptune was named after the mythical Roman god of the sea. The planet appears blue because its methane absorbs most of the red in the spectrum, leaving mostly green and blue. Voyager 2 flew by Neptune only 22 miles off its charted course, and only 1 second off its scheduled flyby time. Skimming only 3,000 miles over the planet's north pole, Voyager found Neptune to be a giant ball of melted rock and ice, cloaked in hydrogen, helium, and methane gases, its atmosphere whipped by winds of up to 700 miles per hour. Voyager flew the closest that any spacecraft has come to one of the outer planets, discovering at least 4 complete rings of ice and rock, 6 new moons, and a great dark spot, a hurricane the size of Earth raging in Neptune's southern hemisphere. Dr. Andrew Ingersoll.
The storm revolves around the planet every 18 hours. And then it rotates around its own axis like a big glob of pizza dough every 16 days.
Largest of Neptune's 8 moons, Triton orbits in an opposite rotation from the planet. Triton was once probably an independent object in orbit around the Sun, until it collided with a moon and was captured by Neptune's gravity. Pockmarked by impact craters and glazed pink by a radiation blitz of methane and nitrogen ices and atmosphere, Triton is the coldest known object in the solar system and one of the most reflective. Utilizing Voyager's digitized photographs of this icy moon, scientists saw jagged mountains, high cliffs, and frozen lakes. The most bizarre discovery on Triton was the presence of icy geysers, some of which are still active, spewing organic particles 100 miles downwind. Dr. Edward Stone.
The Voyager mission to the outer planets has certainly been a journey of a lifetime. Having encountered Triton as the last world we would visit, I don't see how any of the scientists could have been happier.
Voyager 2 has set its course for southwest of the constellation Sagittarius. Traveling at 10 miles per second, it is expected to pass 4 light years from Sirius, the brightest star in the heavens, 290,000 years from now.
The spacecraft was 3.7 billion miles away from Earth, so far away that it took each pixel 5.5 hours, traveling at the speed of light to reach us. From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
In July 2015, NASA will discover a new world. No one knows what to expect when the alien landscape comes into focus. At this point, only one thing is certain. Its name is Pluto.
At this very moment, one of the fastest spacecraft ever launched, NASA's New Horizons, is hurtling through the void at nearly 1 million miles per day. Launched in 2006, it has been in flight longer than some missions last, and still has 4 more years of travel to go. New Horizons is headed for the lonely world of Pluto on the outer edge of the solar system. Although astronomers now call Pluto a dwarf planet, it's actually a large place, about 5,000 miles around at the equator, says Alan Stern, principal investigator for the mission. And it's never been explored. Indeed, no spacecraft has ever visited Pluto or any dwarf planet in the outer solar system. This is a whole new class of worlds, says Stern. To understand the solar system, we need to understand worlds like Pluto. Pluto is a resident of the Kuiper Belt, a vast region beyond the orbit of Neptune. Stern believes the Kuiper Belt contains 1,000 dwarf planets or more, a whole zoo of them. Dwarf planets are, in fact, the most numerous class of planets in the solar system, and probably in the whole universe. Pluto is a world of mysteries. For one thing, Stern wonders, what are the molasses-colored patches on Pluto's surface seen by the Hubble Space Telescope? Some scientists think that they could be deposits of primordial organic matter. New Horizons spectrometers will help us identify the kinds of organic molecules on Pluto. We expect to find something pretty interesting. Hubble recently contributed more intrigue by spotting a new moon circling Pluto, bringing the total to 4. Composite Hubble images of Pluto now resemble a miniature planetary system. New Horizons will hunt for even more moons as it approaches the dwarf planet. To aid in the investigations, New Horizons is carrying one of the largest and highest resolution interplanetary telescopes ever flown. It's called LORRI, short for Long Range Reconnaissance Imager. At closest approach to Pluto, LORRI can resolve details almost as well as a spy camera. The view will be incredible. If we flew this instrument over Earth at the same altitude as we plan to fly over Pluto, we would see individual buildings and their shapes. What will we see on Pluto? Some researchers predict icy geysers like the ones on Neptune's moon Triton. Some say we could see those surface deposits of organic material. Stern says simply, there could be all kinds of surprises. It's a first exploration of a new kind of planet. New Horizons is scheduled to reach Pluto in 2015.
Are we there yet? One of the fastest spacecraft ever built, NASA's New Horizons, is hurtling through the void at nearly 1 million miles per day. Launched in 2006, it has been in flight longer than some missions last, and it is nearing its destination, Pluto. The encounter begins next January, says Alan Stern of the Southwest Research Institute and the mission's principal investigator. We're less than a year away. Closest approach is scheduled for July 2015, when New Horizons flies only 10,000 kilometers from Pluto. But the spacecraft will be busy long before that date. The first step in January 2015 is an intensive campaign of photography by the Long Range Reconnaissance Imager, or LORRI. We need to refine Pluto's position to get the best encounter, says Stern, so we have to home in on it by photographing the planet against known background star fields. We'll use the data from LORRI to refine Pluto's distance to the spacecraft, decreasing the uncertainty from a couple thousand kilometers, and then fire the engines to make any necessary corrections. At first, Pluto and its large moon Charon will be little more than distant pinpricks, a couple of fat pixels, says Stern, but soon they will swell into full-fledged worlds. By late April 2015, the approaching spacecraft will be taking pictures of Pluto that surpass the best images from Hubble. By closest approach in July 2015, a whole new world will open up to the spacecraft's cameras. If New Horizons flew over Earth at the same altitude, it could see individual buildings and their shapes. Stern is looking forward to one of the most exciting moments of the space age. Humankind hasn't had an experience like this, an encounter with a new planet, in a long time, he says. Everything we see on Pluto will be a revelation. Other than a few light and dark markings seen from afar by Hubble, Pluto's landscape is totally unexplored. Although some astronomers call Pluto a dwarf planet, Stern says there's nothing small about it. If you drove a car around the equator of Pluto, the odometer would rack up almost 5,000 miles, as far as from Manhattan to Moscow. Such a traveler might encounter icy geysers, craters, clouds, mountain ranges, rills and valleys, alongside alien landforms no one has ever imagined. There's a real possibility that New Horizons will discover new moons and rings as well, says Stern. Yes, Pluto could have rings. Already Pluto has 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Numerical simulations show that meteoroids striking those satellites could send debris into orbit, forming a ring system that waxes and wanes over time in response to changes in bombardment. We're flying into the unknown, says Stern, and there's no telling what we might find. One thing, however, is sure. We're almost there.
On July 14, 2015, NASA's New Horizons spacecraft will make a close flyby of that distant world. Because Pluto has never been visited up close by a spacecraft from Earth, everything we see will be a first, says Adriano Ocampo, the program executive for NASA's New Frontiers program at NASA headquarters. I know this will be an astonishing experience, full of history-making moments. The mission's principal investigator, Alan Stern of the Southwest Research Institute, has likened the way New Horizons will revolutionize knowledge about the Pluto system to the way that Mariner 4, which flew past Mars in July 1965, revolutionized knowledge of that planet. Horizons' flyby of Pluto will occur almost exactly 50 years after Mariner 4's flyby of Mars, and it could shock observers just as much. Pluto is almost completely unknown. It is so far away that even the Hubble Space Telescope strains to see it. The best images so far show little more than Pluto's shape, spherical, and color reddish. Over the years, changes in those color patterns hint at a dynamic planet where something is happening, but no one knows what. By late April 2015, New Horizons will be close enough to Pluto to take pictures rivaling those of Hubble, and it only gets better from there. At closest approach in July 2015, New Horizons will be a scant 10,000 kilometers above the surface of Pluto. If New Horizons flew over Earth at that same altitude, it could see individual buildings and their shapes. Flying so close to Pluto could be risky business. Pluto has 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Numerical simulations show that meteoroids striking those satellites could send debris into orbit around Pluto, forming a debris system that waxes and wanes over time in response to changes in the bombardment. During the approach to Pluto, the science team will keep a wary eye out for debris and guide the spacecraft away from danger. The New Horizons team continues to do a magnificent job in keeping the spacecraft healthy and ready for this incredible rendezvous, Ocampo says. The spacecraft is in good hands.
Bladed terrain is this bizarre landscape that's made of a series of aligned, very steep ridges that are reminiscent of a drawer full of knives with the knife edge pointed up. And they're maybe 1,000 to 2,000 feet high, and they have very steep slopes, too steep to climb up, and their origin and evolution was initially a total mystery to us. After many, many months of work by our composition team, they told us it's made of almost solid methane ice, and this methane ice seems to only reside on the highest points of Pluto. when we realized that related terrain were big deposits of methane ice, we asked ourselves, why does it form all these ridges as opposed to just being big blobs of ice on the ground? And it turns out that Pluto undergoes climate variation, and sometimes when Pluto's a little warmer, the methane ice begins to basically evaporate away, which the fancy word for that is sublimation. And this is a form of erosion, so this evaporation erosion creates these contorted, blady landscapes. There are indeed some really weird things on Pluto we don't understand. For instance, there are things which look a lot like big ice volcanoes. And if they are ice volcanoes, we're not sure yet, but they are enigmatic and they challenge our understanding of how Pluto works.